Hello. Hi guys, good morning. Welcome back to a new video. In this frequency problem, find the number of ways to reach the K-th star. Now, if you are worried about your rating, ranking, you should not, because there was a much cheating happened. Entire proof and stuff was in this short. You can just go and view this. This is our main Hindi channel, again, in which crash courses and other live streams come. Okay, let's come back. So in this, again, this is not that hard, not that easy also, but it's a very good problem and it will teach you one very good thing. I'll teach you that. It says that we are given a non-negative integer k and there exists a staircase with an infinite number of stairs. Okay, stairs are infinite and I have some integer k. The lowest stair is at numbered 0. So I can say lowest stair is number 0. Now they have numbered, like for them the stairs are I itself. You can see that stair I minus 1, stair I plus. So they have I. So like they are naming the stairs as I. So they are saying that initially I is equals to 0. That's what they mean. Cool. Now it says that with the initial value of 0, jump. So there is another variable called as jump, and that is having initial value of 0 itself. Now there is a girl, Alice. Now she starts on stair 1. So she not start here. She will start at I equal to 1 and want to reach to a stair k. As you can see, I have given an integer k. So there is some, as you can see, it is infinite stair. So I want to reach some I is equals to k. That's my aim. That's my maqsad. That's my goal. Cool. Using any number of operations. And there's no boundation on the operations also. I can take any number of operations. If she is on the stair I, in one operation, she can. Again, now they are saying that if she is on a stair I, in one operation, she can either go down to the stair I minus 1. From the stair I, she can go down to stair I minus 1. Or again, but they have put a condition that the operation cannot be performed consecutively. Which means if she has just performed a down operation, she cannot perform the next down operation right now. That's not allowed. And also, if she had, maybe if the I was here, what if the I was here? She performed a down operation. Okay, good. What if the I was here? Now she cannot perform any down operation because I is 0. From 0, she cannot go into Patal, right? Okay. So, as in like Nark. Cool. Now, so if the stair is 0, then also she cannot go down. If she has gone down just right now, still she cannot go down because she cannot go consecutive downs. Okay, the next operation was she can go up as in if she is at I, she can do a I plus 2 raised power jump. I plus 2 raised power, she can do I plus 2 raised power jump. This is a new stair she will land onto, right? And again, when this is done, when this jump is done, the jump will increase to jump plus 1, which means the next time, let's say here the jump was a 0. So okay, she did I plus 2 raised power 0 jump. Next time from here, she will have to do a jump of I, whatsoever I is this, which is, let's say this is the new I plus 2 raised power 1, which means jump has increased. Now ultimately my main aim, maqsad, is to find the total number of ways. Okay. And again, it is specifically mentioned that it is possible to repeat stuff, which means that it is possible that Alice reaches the stair k and performs some operation to reach the k stair again. As you can see in this example, when k is 0, you can easily see Alice started from I is equals to 1. She wanted to reach to a stair k is equals to 0. So one operation, one way could have been she could have just do a down jump. But she still did not stop here. From this, again, she reached in one way. In one way, she have reached k equal to 0. So ideally, answer should have been 1 because from this she had reached my 0. No, answer can be more because from this, now if you remember I equal to 0, she can now still do a jump. Which means she can now, again from the existing I, which is 0 plus 2 raised power 0, she can again reach on to I equal to 1. Now from here, as you can see, previous jump was a up jump. Now she can again do a down jump, right? Thus again she reached on to 0. So one way to reach on to my k equal to 0 is just a down jump. Another way to reach on to k equal to 0 is down jump, up jump, again a down jump. Thus I have two ways. So that is what the last thing is saying. Now let's try to understand what is the k. K is very large. K is 1e9. So if I just try to visualize what the problem is saying, problem initially starts from I equal to 1. Let's take a different color. It is from I equal to 1. Now, I will show you both the options. Firstly, let's see only the up jump option. Let's say I am doing only the up jump. If I am here, I will do a simple up jump to I, existing I, plus 2 raised power 0, because it's a first jump. Jump is initially 0. So it will be 2 raised power jump. Jump is 0. So now I will be at 2. Okay. From here again, I'm just trying to go up. I'm doing only the up jump, let's say. So again, from here, I can do again up jump. I will reach on to existing I is 2 plus. Now it is the next jump. So jump value has increased to 1. So this will be 4. Now I equal to 4. So from I equal to 2, I reach to I equal to 4. Okay, no worries. Again, now I equal to 4. From I equal to 4, I again did a jump. Now again the jump has increased. So now I reached on to I equal to 8. Again from I equal to 8, I jump. I did again a jump. As I am saying, again a jump, which means jump value will again increase. So it will be I equal to 16. So if I roughly see, I am actually jumping 1, 2, 4, 8, 16. So if I just ask you, if I keep on doing the up jump, how much maximum I can go? How much maximum I can go? I will say, Aryan, at max I wanted to reach a 10 raised power 9 as a jump value. And now in this case, I'm jumping in the powers of 2. So it is very obvious that I will say, okay, I'm jumping in the powers of 2. For sure, I have some I plus I'm jumping in the powers of 2. As soon as, again, my limit is to reach K. If I reach beyond K, okay, it's of no use to me. So I will ultimately say if I reach beyond K, it is of no use. So roughly, if I just even ignore this part and I replace this K value, the maximum K value, I am ultimately saying that my X, if I keep as 32, again, 32 is the maximum. 32, if I just say to show 32, it is the integer limit. Integer limit is 2 into 1e9, right? So I am roughly saying that if I keep my X as 32, which means on 32 jump, I will for sure go beyond my K limit. So at max up jump can be 32. Cool. Okay. But then you will say, Aryan, okay, are you sure at max jump can be 32? Because you have also seen that I can also do a back jump. Technically, yes. You can do a back jump also. Let's see what can happen if you do a back jump. So ultimately, okay, I showed you this, but still you must be confused. Okay, Aryan, but you have put this limit, you can still do a back jump. No worries. Let's see now the back jump. If I was at 1, I can do a back jump. Okay, I can reach to I equal to 0. Here also I can do a back jump. I will reach to I equal to 1. From here, if I do a back jump, I will reach to I equal to 3. Oh, from here, if I do a back jump, I will reach to I equal to 7. From here, if I do a back jump, I will reach to I equal to 15. But now you will say, Aryan, it seems like I will have only these states. As you can easily see, I will have I equal to 16 and 15, 8 and 7, 4 and 3, and so on and so forth. 2 and 1, and so on and so forth. Which means you are trying to say that you have 32 up jumps and 32 down jumps. Is this what you are saying? If yes, then your answer is wrong. And that's the reason. Like, people have solved it, but they don't know the complexity of this problem. That is because they have not visualized this. So I am saying they can do a down jump, obviously, which means that even if my I ultimately in the very end, I am saying my limit is that I should make my I reach to K. It is not important. Even if I make my I reach to this value, which is, again, my I is just above my K, still I can do one down jump and can come back to my K. I can do one down jump and can come back to my K. So that is completely fine. Okay. So one thing I realized that my I, it can be equal to my K plus 1. Okay. But Aryan, still, you are still saying that the up jump and down jump are 32. I will say they will be more. Let's see how. So as soon as you do a down jump, you can still do a up jump. But if you do a up jump from 3, which was the existing down jump, if you remember, if you do again a up jump, it will be a 7. Oh, Aryan, I reached back to my 7, which was a down jump. So it is still the same states. No, bro. If you reached at 7, the previous step, which was the red step, if you remember, which was the red step was the up jump. So now you can again do a down jump. The restriction was that you cannot do two consecutive down jumps, but there was no restriction that you can do a up jump and then a down jump. So from this 3, I did a up jump and reached a 7. From here I did a down jump and then reached a 6. So ultimately I'm trying to say that, okay, from 8 I can reach a 7 and a 6. Okay, then from again from my number 7 I can again go and reach my 15, because it was a up jump previously. Now I can do a down jump and I can reach my 14. And the same way you can say, Aryan, from this 6 I can reach my 14 as a up jump, and then 13 I can reach as a down jump. So you can say I can reach my 13 as a down jump. So roughly, Aryan, it feels like that I can go all down. Roughly, Aryan, it feels like I can go all down. But do you see a very great pattern? As you can see, I have made all the possible up jumps and down jumps. There is no other possible up jumps and down jumps so far. Can you see a very great pattern? That here we have 3 down jumps. Here we have 2 down jumps. Here we have 1 down jumps. Here we have 1 down jumps. Here we have 1 down jumps. So the thing which I'm trying to show you is that a down jump is only and only possible if I have done a up jump previously. Right? So this is the very great fact that a down jump is only possible if I've done an up jump previously. And if I tell you how many up jumps were possible, as I showed you earlier also, there are at max 32. Again, this is the worst to worst case. 32 up jumps possible, which means these up jumps, they can be at max 32. Which again, when I say the 32, which means again these up jumps can at max be 32. These main up jumps can at max be 32. Now I am saying that for 32 up jumps I can have, what is this? I will realize every contribution of a up jump, every contribution of a down jump, as you can see this green one, was because of a up jump. And I told you at max up jump can be 32. So how many down jumps can be possible for a specific, again, let's say, again, when I say specific, I mean, like, let's say for this portion, this is one portion, this is one portion, this is one portion. So for this portion, how many down jumps can be possible? That can be at max 32. Why? Because I showed that every down jump is corresponding to a up jump, and I know at max I can have 32 up jumps. So this pink thing can be at max 32, right? So considering the same thing that they also might have been pink of someone, don't go into that sense, but yeah, I can easily say that I can have at max 32 down jumps, at max 32 down jumps, and that too is only possible for the extreme one. As you can see, it will keep on increasing. Here the jumps are 2, here the down jumps are 2, here the down jumps are 3, here the down jumps are 4, next one will be 5, next one will be 6, next one will be 7, at max 32 down jumps for every corresponding up jump, which means this, and here it was this. So we realize at max number of operations can be 32 into 32, 32 up jumps for every corresponding limit, which is this thing, main banda. There will be at max, can be at max 32 down jumps, 32 down jumps. So this is the complexity. But do you see something being repeated here? As you can see that if you are at I equal to 8, still you can reach to I equal to 7. If you are at I equal to 3, still you can reach to I equal to 7. So we can see, okay, I can reach my I equal to 7 with 2 directions. Although you can easily say that, okay, it can be a repeating sub problem which I should satisfy, which I should make sure. But if you look very closely, then again, first thing is that it is having a repeating sub problem. If you try to recursively solve it, it will have a repeating sub problem. That's obvious. But still, you can also solve it without even First thing is a recursion, and you can also solve it without even making sure that you memorize stuff, right? Although even if you memorize, you know at max number of states are 32 into 32 into 32. So space and time can roughly be 32 into 32. This is both space and time. So still both will be constant, but for your fact, for your curiosity, I'm still showing you that, as you can easily see, that you can simply represent this as iterative form also, and you know that you can just go one down and again you can come one up and then one down. So at any point you can reach on at max by two like positions, either coming from somewhere else down or maybe coming from somewhere else up and then going back to down. Cool. Now we realize that this is the case for us. Now let's simply start to write the code for it. So if I write the code, I will realize I am at a specific state I. I have two options. Either I can go down, which means I minus 1, or I can go up as in I plus 2 power jump. So I will realize in my recursion, I will for sure need a variable I, because from I am changing my state of jumps. And then I also realized that, okay, I should also maintain this jump variable, because after every jump, this jump variable increases by 1. So I have to also maintain this jump variable. So jump is I will maintain, I is one thing I will maintain. And then I also know that I should actually go back, but I cannot go consecutive backs. So I should also maintain that was the last jump was a down jump. If the last jump was a down jump, I cannot repeat the down jump again. I have to maybe somehow do a up jump, and then again I can try for down jump, which means I have to also maintain if the last jump was a down jump or not. So I realize again, this I will be the number of states which I can have, and we saw that the number of points which we can have is 32 into 32. And then we realized that we can have a jump. Jump we also saw that at max can be 32. We can have at max 32 jumps. And was the last position down or not? That is simply true or false. Yes or a no. So it will be O of like 2. So this ultimately can be our, again, this will be much less than this, because this is for I, which we have taken. This is for jump, and this is for Boolean array, which is was down. So we realize again, this will be much lesser than this. My I will be actually much lesser than this, as we saw that, because it is increased. Okay, one down jump, 2 down jump, 3 down jump, and so on and so forth. That's the reason this will be less. But still, this will still work in a complexity. I just still need to do a simple recursion and then memorize. Now let's write the simple recursion. Solve function starting from my I and then my down jump, if the last jump was down jump or not, and then what is the initial jump. So from my main function, I will say solve starting from I equal to 1, because if you remembered, my staircase in the very beginning was I equal to 1. Where is 1? Yeah. No. So, okay. Stays somewhere it is written that she starts from stair 1, because we start from stair 1 itself. Cool. So my stair is initially in the very beginning 1. Down jump not done previously, so it will be 0, which means false. Jump initially in the very beginning is 0. So this is what I will pass in from my main function. Now, in a very simple recursion, we have a few stuff. Base case, like initialization of the variable, recursive case, and then return statement. We know it's a DP because of states we are memorizing, so we will simply maintain the DP. Now we realized that my number of states of I are actually, number of states are known at max. States are known for I. That's okay, that's obvious, but it can be from 1 to 1e9. So I cannot make an array, I cannot make a DP array of this big size. I have to take an unordered map. Only those states should be memorized, which I am going on to. So I will, instead of keeping a vector of I will take an unordered map of I, basically a hash map of I. Now, okay, we'll go on to base case later on. We'll always go on to base cases later on. Firstly, we know that we will have 3 states, my I, my jump, and my was down, previous was down. Then I will just simply memorize it. Right now I showed you it will be an unordered map, so this will not work. I have to simply do a dp.count to check if this I is present or not, right? This is how we do it. I'll show you in the code, but -1 will not work because now it is an unordered map. It is not a vector. Now I will initialize my variable called as answer because I want to know the number of ways to reach my k. Now, simple, I have two options. I have two choices. Either I will go up. If I go up, I was at I. I will go up from I to 2 raised to the power jump. You can also write it as 1 left shift jump. It's totally up to you. And then after performing this operation, we know that currently this was an up jump. So I have marked as a 0, which means that as you can simply see that this will go on to this will go on and repeat. This shows this is a variable called as down jump. Was the previous jump as down jump? As I have done right now in front of your eyes, I have done an up jump. So I will say the current jump is up jump. For the next variable, which you will try right now, you can assume that previous jump was a up jump. So it is 0, 0. And then jump will remain as it is. What if I try for down jump? I can try for down jump considering my I is not 0 and I did not do a down jump previously. Only then I can try for down jump. So I'll try for down jump, which means I minus 1. And again, sorry, here the jump will increase by 1. Cool. Here the jump will remain same. And just to keep it that the current jump was down jump, next time you cannot repeat this process of down jump again. Okay, recursive case done. And ultimately you can simply memorize your I was down jump and then memorize it. Few things are remaining. What is the initialization condition? Okay, we'll go on to it later on. Maybe we can just initialize by 0 because we have no options or no ways or no operations in the very beginning. But still, you can just simply say, Aryan, what's the base condition then? One base condition we already saw is, what if my I reaches beyond my k? Reaches beyond my k. I realize that, okay, what if my I reaches beyond my k? Then I'm kind of screwed up. I cannot go kind of, like if my I reaches beyond my k, which means my I is here. I somehow reached my I here. I know I can, from here, I can either go up or I can go down. So if I have reached my I equal to k, which means, okay, it's a good step, it's a final step. And if my I is actually equals to k plus 1, which means my k is just below. If I do a 1 down jump, I will also reach my k. So ideally, that I should make sure that if my I, again, I can either write as, okay, if my I is equals to my k and sorry, if my I equal to k, or I can say that, okay, the previous jump was not a down jump, and my I is equals to k plus 1. Then I know that because of this operation, I can do a 1 down jump and I can reach back. So I can simply return a 1. And I can simply say, if my I is more than my k plus 1, there is no possibility to reach to my k, because I know that I can either do 1 down jump or up jumps. That's it. If I have reached somewhere, which is, let's say if my k would have been 5, but I have reached, let's say I is equals to 8. So there is no way from here I can either increase it or decrease only 1 down. There is no other way to decrease much more downs. So there is no way I can come back to my k equal to 5 step. So if my I equal to more than k plus 1, simply return a 0. So that could have been a simple logical condition. But then there is one thing which is missing here. Do you see very clearly what's missing? The missing thing is that you have assumed you will stop if you reach at I. If you reach at k, or if you reach at k plus 1, where the step is k plus 1 or where the step is k, you will stop and return from here. That is problem was saying this is not good. You have to still go and try. Even if you have reached a stair k, still you should go and try. Still you should explore. It is the same way. Your X is not satisfied with one guy. But yeah, cool. So what we will do? Okay, we will simply remove this line because we cannot simply return from here. We cannot stop. We cannot limit ourselves with this line. We cannot stop here. We ultimately will say, okay, if I have reached my k, then I will initialize. Then I will say, okay, answer will be 1. If I have reached my k, my answer will be 1. Then I should have an opportunity to go and try up, to go and try down, to go and try up, to go and try down. Only if I am trying to go up, then this will make sure then this will make sure that I am kind of returning back. And also if I try to go down, either it will be a good state, which means either it will be less than my specific k plus 1, or if it is more, okay, if it is more, then he will stop it. If it is less, it will still come inside, but then it will still have an option only to go up, because last time it came in from going down. Cool. And thus it will ultimately start, like it will try to visit all the possibilities of place which he wants to visit, but I'm not restricting him by myself. I'm not saying to stop at that location. I'm saying go and try as much as you can. He will try as much as he wants, and then ultimately if the states are no more or all the states are visited, then only he will stop. And that's the main crux of this problem, that this is one such problem in which you never returned from the base condition because you want him to try as much as he can. You never restricted him to stop when you got the answer. No, you never restricted him to stop when you got the answer, and that's the main beauty of the problem. Cool. Let's see. Again, the video went a bit long because I want to explain you every condition in this. The condition is how the complexity is, what it is, what are the number of states, and how we're actually solving it, and how this is different than that of the standard DP. You should know the time complexity of your DP state which you have written. Cool. Now let's see the code again. Simple base case, when I equal to more than k plus 1, simply have a 0. Here, as you can simply see, I made an unordered map. This is for I. This is for my saying was last down jump, just to show if the last jump was a down jump or not. And this is to say, okay, what was the jump? I can easily show you that this was actually 32 into 32. This was a 0 or a 1, which is 2 states. This is at max 32, right? Again, I'm saying it will be still very less than this value because it is 0, because it is for let's say it will be 1 into 1 plus 1 into 2 plus like 2 into 3 and so on and so forth. So this is how it is actually going above. Now that again, you can easily take an unordered map for this only state I. For others, you can take a vector also, that's also fine, but I have taken entirely a vector, unordered map. Now if I is there, was down jump is there, and my jump is there, I will simply memorize this and simply return the value whatsoever is memoized. If not, then try for a state. If I have reached my k, then increase the answer by 1, right? If not, then simply try to jump up, try to jump down, and simply return that memoized answer. And ultimately try to jump from the stair 1. Initially the was down will be 0. Initially the jump will also be 0, and ultimately return the answer. I have taken a long, that's not required. You can just simply take an int also, that will simply work. And that is the answer. Again, the time for this is 32 into 32 for my I, into 2 for my was down jump, right? Was down, and into 32 for my jump. And space again will be exactly same as time because we have used an unordered map or a simple hash map for I. It can be improvised because as I showed you how the iterative version will actually work, it can be still improvised to only accommodate this. Only accommodate this. I would not be needing entirely this. If I convert this somehow to make sure that I'm only going on to the required state, required jumps, right? Thus, again, if I do go like iterative, so space will like no space will be there, or you can still say the space will be constant, but still I'm showing you there's a possibility of improvisation, but still considering that we have reached to a state, this will actually work. And this is actually the most intuitive and optimal solution. Not optimal, but most intuitive. Optimal can be if you bring down and remove this 32 by just removing that jump thing and incorporating everything to I itself, which means making sure the jump and you are finding the specific I and number of jumps simultaneously as you go up. Cool. Bye bye. Take care. Thank you. If you have not watched this channel, go and check it out. Again, we have crash courses, we have live streams coming in, we have shorts, all shorts here itself. Bye bye.